Hey, what's up, guys? It's Akshay from AS Learning. It's been a long time, I know. And today in this video, we'll be seeing about machine learning development cycle. So, any computer engineering guy or software engineering guy knows about software development life cycle. Even the folks who do testing, they have their own software testing development cycle. And similarly, on the similar lines, even in machine learning, you have a set of flow which is followed by all the machine learning developers, AI developers, and data scientists all around the world to build incredible models for you. So let's see what MLDC is, machine learning development cycle, with the help of one end-to-end example. So we'll be understanding the entire flow with an end-to-end project. So because the focus is more on understanding the MLDC, I have taken a simpler project, you can say, and the project is regarding Titanic dataset. So it's a very renowned dataset, and most of the people know what exactly is Titanic dataset problem and all. But still, I'll repeat for the guys who don't know. So let's do one thing. Let's first look at the MLDC, and then parallelly, while explaining the problem definition, I'll be explaining what exactly is Titanic dataset problem statement. So this is how the ML development cycle looks like. We have the first thing as problem definition, second as data selection, third is exploratory data analysis, then we have data pre-processing, transformation, feature selection, model training, model evaluation, and model deployment. And that is how an entire machine learning model is built. Okay, I've picked this image from Ignite TCS. Okay, so let's just understand this entire MLDC with the help of Titanic machine learning problem. Okay, so first of all, let's in the first step, problem definition or a problem statement. So the problem statement here is to build a model to tell if any person survived the Titanic incident or not. So they need to build a machine learning model with the help of which any input of any passenger on the Titanic will be its input, and then the output will be getting whether that passenger survived that incident or not. Okay, sounds cool? Yeah. In the first step, it's a very important step. I'll tell you why. Because you, as a machine learning engineer or a data scientist, should know whether this is a machine learning problem statement or not. So many of the times you try to include machine learning into solving something where the things can be done using some basic SQL queries. So that should not be a case. You should really have a very clear understanding that whether a model needs to be built here or not, or what kind of learning approach needs to be here, whether it is database supervised learning or any rule based learning or some any other form of learning. But it should be very clear, like whether a model is really needed here or not. Okay, moving to the second step, that is data selection. So here I've downloaded it from Kaggle, and I'll also upload the data set on GitHub, so you can download it from there. Here is my GitHub link. You will get this notebook also in my GitHub, so no issues there. In real life, you have data sources into various DBs like Postgres, maybe Amazon S3 or Amazon Redshift, uh, any other DBs. Like if it is a non-SQL DB, then it's MongoDB. So there are different kind of DBs where this data is stored, and then you build a model and you fetch the data from there, and that is how it works. So you have the in real life conditions into IT, you have data into these DBs. Okay. Then the next step is exploratory data analysis. So what in exploratory data analysis we try to do is we try to make sense of the data. How are the independent features interacting with each other? What is a dependent variable? How is the independent features are impacting the dependent variable. So you try to make an analysis of the data. Okay. So here in the data set, you will see that you have two CSVs. One is train test. Okay. I'll give you a glimpse of those CSVs. So this is my train.csv and the other one is test. So there is nothing difference between both. The only difference is that in train you have your dependent variable survived and in test you don't have it. So these are the features, okay, and this is my dependent variable here survived and all the other are my independent variables. So you have different variables like passenger ID, you have P class, that is in which class the passenger was there, then you have the name of the passenger, okay, and you have its gender, you have age, then the number of siblings the passenger had, the number of parents and children he had on the ship. Then you have the ticket number, you have the fare of the ticket, you have the cabin which was allocated to him, and from which port did he embark. So Titanic was embarked from three ports, and those three ports are mentioned here. Okay, so this is in rough for what the data is, and we'll try to make sense of this data into EDA process. Now here I've just read the file, okay, train.csv, test.csv. Here I've added a 1 and 0 because I'm creating a differentiating element on the on the train and test CSV. Okay. Then here's just a normal head. Here are my columns. Here I'm concatenating the train and test because whatever pre-processing activity, analysis, and transformation activities I'll be doing, it will be on both of them. So I don't have to repeat the process. Okay, here I'm checking whether are there any duplicate entries or not. Okay, so this piece of code does that, and yeah, finally we can see that all the entries are distinct. Okay, after handling the duplicacy, so here in this piece of code we handled whether we had duplicate rows or not. And later on, we moved our attention towards handling the missing values. Okay, so here this function is any not sum. We can see that in survive we have 418 missing values, and that is supposed to be because these missing values are of the test.csv in which we have the survive column entirely missing. So this is fine. But in age we have 263 missing values, then in cabin we have 1014 missing values. So this is a lot of missing values. Okay. Then this is a normal disguise function in which you get to know the count, the mean, standard deviation, minimum, maximum, the percentile values 25%, 50 percentile, 75 percentile, and these kind of values are regarding the data. Okay. Now what I'll try to do is we have to see whether which of the feature are impacting my dependent variable. Okay, so first I analyzed P class, how P class is creating an impact on the survive dependent variable. So here we can see that the patient who were of first class, they have a higher ratio of being survived, and it makes sense because the people who might be in the first class, they might be richer, so they might have got the access to the surviving boats first. Okay, so it makes sense. Then we have the analysis of sex versus survived. So here we can see that the females have a very high survival percentage than male. It also making sense because way back in when Titanic actually happened, and even today also we see people giving first priority to females and children, and males are left behind. Female को पहले जाने दो, after that male. So that is why female have a high survival rate here. Okay. Then we did an analysis on the siblings part, and here we can see that the one who is having a larger siblings, his survival ratio was less than the one who were having lesser ones. This also is making sense because generally when you have a larger crowd of family, You try to make sure that all of them are together. You try to make them together, and then you make sure that everyone is getting its equal chances. So there's a lot of effort involved there, and as compared to that, if someone who is not having siblings, the first thing you'll try to do is run towards the safety port. It's making sense that the ones who is having larger siblings will have lower survival chances. Same with parent and children also. You can see that the ones who didn't had parents and children were having higher survival rates. Then what we try to do is we combine the siblings and the parent column, and we included them into one called family size. Okay, we added a one because this one is for the individual himself. Okay, now this step doesn't comes into EDA. This step will come into data transformation. Okay, so this is my bad that this cell is coming into EDA, but this is into data transformation. Okay, now next we'll move on. Now once we're done with the EDA, we'll go towards data processing and data transformation. Now here what we try to do is we convert all the categorical variable into numerical. Why so? Because a computer can't understand categorical variables. Okay, so here I've applied a lambda function and I'm converting all the k-bin from categorical to numerical. Okay, then what I'm trying to do is here I'm handling the missing values. Okay, I'm doing a fill NA of S of embark, and because the mode of the embark must be S. Okay, that is why I am filling it with S mode. Then in age I'm using mean, and in fare also I'm using mean. Okay, and I'm dropping the other columns: name, ticket, passenger ID, and cabin. Cabin because I've just made a transformation of it. Then what I'm here also trying to do is, if you can see, the ones with the cabins have been allocated a value of 1, and the ones who are not with the cabin are allocated a value of 0. In cabin we had distinctive categories, like there was no one such category, but it had the cabin number with it, like G6, C103, E46, and C123. Okay, so the ones who had cabin, they have been allocated 1, and the ones who didn't have been allocated 0. Trying to make it simpler. Okay, now I've dropped cabin, I've dropped passenger ID because that is not needed. I've also dropped ticket and name here, but you could have done more with the ticket and name. Like in name, you can see that many of the people have their own designations like Mr., Mrs., Doctor, and also you could have explored more and it could have been done that you could have taken this insight also. Okay, even in tickets also, maybe we could have searched for some kind of a pattern if there is any. Right now, nothing is striking me in tickets, but yeah, maybe a bit more exploration would be needed here. But in names, we could have done with Mr., Mrs., Miss, and all. But right now, I am just dropping it out because the ultimate aim in this video is understanding machine learning development cycle and not to build a Titanic solving model which would get a good rank on Kaggle. Okay. So I'm using here a normal label encoder. I'm doing a fit transform to convert sex into numerical thing. Okay. Then here into label binarizer, I've been using label binarizer for embarked. Okay, because it was having three values, so I went with label binarizer. You could have also gone with label encoder here. It would not have made much difference here. Okay, generally how this encoding techniques work is whenever you have an order into the categorical variable, like let's say low, high, very high. In such cases, it's a very good practice if you do a label encoding like 0, 1, 2, 3. Okay, because in that cases the order is maintained, the information order is maintained. But when you have this random categories like let's say red, green, yellow, no order, nothing, in those cases doing a label binarizer or one not encoding is a good practice. Okay, then I created a data frame out of it. I handled the index, I concatenated it, and this is my final looking data set. Okay, I have to drop the embarked here because I've converted this embark into these three columns. Okay, so I'll be converting this embark into these three columns. and this is how my final data set appears. Okay, so all these things basically comes into data pre-processing. If you would have now this step of when you combine these two columns into one, this goes into data transformation. Okay, and the other things like handling missing values and all, these are all into data pre-processing. Okay, converting these values into numeric can become into data transformation. Okay, now finally we have to do feature selection here. So here I'm taking all the features as of now because all of them were pretty much significant. The ones which were not, like passenger ID and other things, I've dropped them up. So I'm selecting all the features here which are there, and here I'm starting with the model building thing. So here what you can try to do is you can fit many models, like this is a classification problem, so you can start with logistic regression, then go with decision tree, then go further with random forest, XGBoost and all. So that is how approach goes here. Just because it's a model building phase, I'm here is example. I've taken logistic regression, I've imported it and I have fitted it. Okay, and then once it is fitted, I am doing a prediction. Okay, and after that, there's a step called model evaluation. Well, I'll be evaluating my model. So here I'm evaluating on the basis of accuracy, recall precision, and ROC, AOC score. So I'm checking everything here. Okay. And it is pretty much decent. 80% accuracy is not bad. Okay. And finally, we move towards model saving and deployment step. So what you can do is you can use JollyLib or Pickle. You can save the model and then you can reload the model once again. So it works on the concept of serialization and deserialization. And once you have load the model, then you can do the predict once again. Now, how you will fit the model into deployment? What you can try to do is, if it's a Python-based environment, all you have to do is just write a simple Python file and integrated that into the code base. If they want the API, then you will have to write an API for it. Okay, and then accordingly it will be exposed and used by the front end. Okay, all you have to do is just add a simple function, and accordingly the environment is you will have to fit it, whether it's a Django, Flask, or any normal Python environment. Okay, so that is how it will work in your file system. You will have this pickle file, and in the Python function you will be loading this pickle file, and then the data would go as inputted. Generally how it works is in UI, user takes the input, then that UI input comes as a JSON to this API, and then you have the result of prediction there, and it goes back to the UI. Okay, that is how you will be doing your model saving and deployment. Okay, so just a small recap once again. We understood what the problem statement was, we understood what a data selection is, then we saw the EDA, then we went with data pre-processing, then we saw what data transformation is, we did feature selection, we didn't really a model selection, we just saw logistic regression. What you can try to do is you can fit many models and see which is the best one for you, and then you can select that. Then you do, now this is a very one of the two things: you train your model and then you make a selection. I'll say model training should be first and then you should go for the model selection. It should be below this. Okay, and then you have model evaluation and finally model deployment. Okay, that is how machine learning development lifecycle works, and that is exactly how we do it into IT also and into production on with the actual clients, and that is how it's done. Okay, so if you like this video, give it a thumbs up. If you have any doubts or any queries, just comment it down, and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.